I don't need to understand what, to try to understand what this means. I know what this means, but you don't need. For instance, the first one, simply check whether there is some host available, etc. This is remote procedure calls when you have, when you would like to use computation from a distance machine, etc., etc. So with this action, this actions will be the leaf, the variables set of the network. So it's very easy to define the set of variables of the network. This is actions that are reported by the intrusion detection systems. So we have preprocessed DARPA data sets, exactly like, and we got a table with 44 windows. So it's very small. From this table, we learned the naive Bayesian net. There is exactly one root node, which is the DDoS, whether there is a DDoS or not, and the actions are the 11 here, which are reported. As you can see, there is no extra knowledge required by expert. So this is naive Bayes. It doesn't matter, just the two values of DDoS, true or false, and false with 91%. And a priori, there is no DDoS attack. It means that from the traffic, there is a priori, without any additional actions, there is no DDoS attack, and there is a very low probability that an attack happen. And this is conditional probabilities for each actions. This is, for instance, for one action. What happens if one action is observed? It's not surprised that A1 has even a negative influence on DDoS, because A1, what is A1? It's ACMP ping. ACMP ping just check whether a host is available or not. You can use it for different purposes. It's not related to DDoS attack. This explains why it's because you can find it in different, for basically when you want to, when the connection is slow, you make some pings just to see if everything is fine, if it's nothing special. Now when we have learned this Bayesian net, we took the test scenario provided by DARPA, and we ran it again, and we have seen whether we predict or not. So we take two examples. The one where we know there is a compromised host. This data wasn't used in training. It's really a test. It wasn't in the training. So at the beginning, the probability of DDoS is very low, 8.7. Then first, we receive evidence of A1. The actions has been reported. So each time that an action is reported, we compute new probabilities. Here, the probabilities decrease. Of course, I forget to mention that we need to I don't know where it is. We need to fix some time out, because after 2 hours, we know there is no DDoS attacks, because DDoS attacks takes at most 2 hours. So each time that an alert is received, we update it. I mean, we put A1 is true. Then we put A1 is true. We compute a new probability distribution. Then A2 is reported. We put A2 is true. We compute new probability distributions, etc. And after observing the third actions, the probability becomes very high, and we launch an alert. And then indeed, in this case, there is a compromised host. Now we took another example where there is no uncompromised host. We detect all compromised hosts and all uncompromised hosts. But it's not a big deal in the sense this is a benchmark, well-known benchmark, and it is done in the way. I mean, it's not realistic data. I mean, it's a really benchmark. So it wasn't hard to detect it. Even with precondition, post-condition, we were able to detect it. But just to illustrate, this is the aim. So again, we observe A1, A2, A6, and A11. And in this case, the time exceeds 2 hours. When it exceeds 2 hours, we can confirm there is no DDoS attacks in this case. So, okay. So this is the DARPA benchmark. And with DARPA benchmark, the advantage with precondition, we didn't spend a lot of time to define precondition position. We have done nothing. I mean, just we need the time where for training, the time where DDoS has been observed. That's it. Everything has been done automatically, and we are able to detect all DDoS attacks, and also to correctly, when there is no DDoS attack, to say that there is no DDoS attack. So that's very good. The second data, and this is quite an ongoing work in progress, because it concerns, it's within French national project, and this is more problematic. Even we get good results, preliminary good results. Because recall first that in the first benchmark, there is just 11 actions, which is not too much, which is not a lot, sorry. With this data, we have more than 200 variants of actions. Well, the number of actions is very huge. And there is 3 months of detections. 3 months of detection corresponds to 1 million alerts. It's very high. There is a distribution in terms of severity. Most of them, fortunately, are low. It doesn't correspond to real attacks. There are quite high number of medium attacks. Very few of them, about less than 6%, correspond what the EDS thinks that is severe attacks, something serious attacks that we should observe and follow, etc. There is also a distribution in terms of sources and targets. There are 55% internal. It doesn't mean that it's attacks. Huh? The EDS suspect it's attacks. Okay? Especially, for instance, there are some. Well, there are 34 internal, external, and 20 external, internal. This is exactly what we have considered. We didn't consider internal, because we trust people working in the university. We don't care about internal, external. So it's not good, but we more focus on external, internal, because we like to analyze. We have possibilities even to check whether an attack has succeeded or not. While if it's internal, external, we don't know. I mean, if someone from the local is an intruder that try to compromise of machine at distance, we are not able to see whether the attack is succeeded or not. So, however, in external, internal, without any surprise, the number of severe attacks is quite very high. It's more than 20% severe attacks. And in fact, we have just selected 7, just to follow them, 7 of these severe attacks. As I said, there are basically 200 actions that have been used in the system, without including variants of these actions. So it's really impossible to write precondition and postcondition. It's impossible. There is no way. I mean, with 7 or 10 you can try to do it, like in DDoS, but when you have 200 with different variants, there is no hope to do it. I mean, if we take, unless it's a very crucial company or a very important company or something like this,